Oh my. I'm not getting any image here. We good? Is this going to clear up? Okay, I think we're good. Okay, I want to talk about the idea of division by small numbers. Something that my pre-calculus students always have trouble with in the context of graphing rational functions. We have a denominator that can approach 0 and a numerator that doesn't. Okay, well, that's the context. But the problem is that people come out of the educational system not understanding what division means. They learn how to do it, and then pretty soon they put a calculator in their hands and they forget what anything means. They just take the answers and go with them. And you lose the concept and you lose the ability to think in certain ways that are very important in almost any field that requires any kind of mathematical thinking. Okay, so division by small numbers, and I say that the concept is it takes a whole lot of tiny to make something what ain't. Okay? So you can think in terms of grains of sand and buckets of sand. It takes a lot of grains of sand to make a bucket of sand. Okay, billions is easy to come by when you're talking about that. It takes a lot of drops of water to make an ocean. Okay, it takes a lot of tiny to make something what ain't. Okay, so in the context of rational functions, if we have an expression like x plus 5 over x minus 3, if x is really close to 3, the denominator is really tiny. But the numerator being close to 8, because if x is close to 3, x plus 5 is close to 8. 8. That means ain't tiny, but we've already established that tiny is the word that things are modifying here. If we understand the structure of the English language, which is also a challenge. Okay. So, quotient and the quotient's that thing you get when you divide something into something else. The quotient, this is the quotient. X plus 5 divided by x minus 3. Ain't tiny. I'm going to add something here. Really ain't. That is, it's really big. Okay? Tiny goes into ain't tiny. Bad lots there, but lots and lots of times. This has implications. If you're graphing x plus 5 over x minus 3, so here you have a graph, and here you have the a vertical line where x equals 3, x equals 3. Every point on this line, if this is your x-axis, this is your y-axis, and this line's actually vertical through x equals 3. Okay? So if y equals x plus 5 over x minus 3, then you're getting really big results close to x minus 3, close to x equals 3. Okay? So that means your y values are way up there or way down there. Big can be big negative, big can be big positive. To the right of x equals 3, x values are greater than 3, so x minus 3 values are positive. So these numbers get really big up here. To the left of x equals 3, x minus 3 is negative because x values are less than 3. You divide something less than 3, or you subtract 3 from something less than 3, you get a negative. So that the values go down rapidly on this side. They get more and more rapid. The tinier your difference gets, the closer x gets to 3, the bigger your result is, either this way or this way. Now there could be more to it, but this is the idea of how you get asymptotes to the graph. Now the graph of this function, if you're interested, it's taken us a little beyond the main point I want to make. Almost looks like x is not equal to 3 here. Let's fix that. The point I'm trying to make here is about the asymptote. The rest of the graph, well, if x equals 0, then you have 5 over negative 3. Well, what's that? Negative 1 2/3, right? So you have the point where x is 0 and y is negative 5/3, negative 1 2/3. So if here's negative 1, here's your negative 5/3. Then, if x gets really big, x plus 5 and x minus 3 are almost the same. 1,000,005 is pretty close to 999,997. If you divide 1,000,005 by 999,997, you get something real close to 1. And it doesn't matter if x is a negative number, big negative number. If you divide negative 999,997 by negative 1,000,005, you're still going to get something that's close to 1. So the y value 1 the graph is going to be close to the line where y equals 1 when x is big. And the graph has to get close to this line, has to get close to this line. Okay, well, on this side of the axis, on this side of your vertical line, x equals 3, the asymptote, that means the graph has to go way down here, has to go through here, and then it's got to get close to this, so it looks like this. Very simple. It never crosses this line. Just keeps getting steeper and steeper, closer and closer to the line. Now, also, you can see that if x was equal to negative 5, that would make the numerator 0. The denominator wouldn't be 0. So if you divide 0 by something that isn't 0, you get 0. I mean, how many things that aren't equal to 0 does it take to make 0? You don't need any of them. Okay, so at x equals 5, which might be about here, here's where x equals 5. You're going to go through the x-axis. You're going to turn here. You're going to get very close to the y equals negative 1 line. Uh-oh. And I said that all wrong. That was really stupid. Okay? So I'm going to leave it there. The y equals 1 line is up here. And I said when x equals -5, the numerator is 0. So that occurs over here where x equals I'll label it down here, -5. So what I did here, the first picture I drew was wrong and totally ignorant. We got to come down from this line. So we come up from the asymptote through here, and then we approach this line. So it's going to look something like maybe this. And then over here, comes down from way up here, turns around and approaches this line, never touching it. Okay, so that last little bit about the graph, I got careless. Then I realized that my y equals 1 line. Well, that's what happens when you get old. Things happen. So, most important idea, the one I'm trying to emphasize here though, and the one that people have trouble with, and I think because of never having understood what division means, is this idea of a vertical asymptote. We're dividing a tiny number in a number that isn't tiny, and a number that keeps getting tinier and tinier as you approach x equals 3.